ओके, तो यूनिफॉर्म सर्कुलर मोशन के अंदर हमने लास्ट टाइम कुछ बेसिक कंसेप्ट देखे थे, और चेंज इन वेक्टर्स मतलब चेंज इन वेक्टर क्वांटिटी कैसे निकालने का, जैसे चेंज इन वेलोसिटी, चेंज इन मोमेंटम, या चेंज इन सेंट्रिपेटल एक्सेलरेशन, या से चेंज इन सेंट्रिपेटल फोर्स, ये सब चीजें कैसे निकालने का, तो वो हमने वेक्टर मेथड से देखा था। तो अभी आज के लेक्चर में हम थोड़े सर्कुलर मोशन के एप्लीकेशंस देखेंगे प्रॉपर, ठीक है, so that we can understand how to solve the MCQs based on circular motion. Yes. ओके, ठीक है, तो देखो एप्लीकेशंस ऑफ सर्कुलर मोशन, यूनिफॉर्म सर्कुलर मोशन। सो सबसे पहले हम देखेंगे कि इफ सपोज देयर इज अ vehicle, and suppose that vehicle is traveling along a curved road like this. Okay, so when this vehicle is at the highest point of its motion, what happens is the forces acting on that vehicle are, one is the downward force, that is the weight of the vehicle, that is equal to mg, which is acting downwards, and the second force is acting on the vehicle is nothing but the centrifugal force, which is the force acting on a particle performing uniform circular motion, which is always along the radius away from the center. ये आपको याद होगा कि जब भी हम कोई भी सर्कुलर मोशन परफॉर्म कराते हैं किसी पार्टिकल को, तो क्या होता है कि उसके ऊपर एक सेंट्रीफ्यूगल फोर्स काम करता है, जो कि आउटवर्ड डायरेक्शन में हुआ करता है, along the radius away from the center, ऐसे डायरेक्शन में हुआ करता है, and this force is denoted by Fc, which is called as centrifugal force, and this Fc happens to be actually mv square upon r. This is the formula for centrifugal force, and this force acts on every particle which is performing circular motion. Remember correctly. Okay, so that's why we can see this that whenever the vehicle is moving along the curved road or a flyover bridge like this, it will experience the two forces, and in addition to that, the third force will acting on it is either the normal reaction due to the surface of the road. Surface of the road is also pushing it up in the upward direction, and that's why we can see clearly that the equation of motion of this vehicle will be n plus mv square upon r is actually going to be mg, and hence we can say that this n is actually going to be equal to mg minus mv square upon r. ओके, ये एक बात याद रखो ठीक से। दूसरी तरफ ये भी हम समझ सकते हैं कि whenever the same vehicle is traveling along a valley like this, if it is traveling along the concave bridge like this, and it is at the lowest point here, then it will experience the three forces once again. One is going to be the mg, that is the weight of the vehicle. The second one is the normal reaction, that is the provided by the surface, which is upwards, and the third one is the centrifugal force, because it will be downwards, because the center this time is upwards at this point here. This is the center of the circle in which this particle is revolving here, and that's why we can see the center will be above the surface of the road, and that's why the centrifugal force Fc will be downwards, and hence we can say that this normal reaction actually happens to be Fc plus mg. That means normal reaction can also be written to be equal to here ये mg जो है वो as it is, और Fc के बदले हम लिख सकते हैं mv square upon r, correct है. So this is the normal reaction in case of the vehicle which is traveling along the valley like this. So these are the two important applications of uniform circular motion. Remember this correctly. Now we'll see the next thing, that is about, see here, whenever there is a conical pendulum. Okay, conical pendulum के बारे में आपने सुना होगा, ठीक है ना. The pendulum, suppose it is like this, there is a string and there is a ball which is attached to this string, and this ball is of mass m, and suppose this conical pendulum is just stretched by some distance, and suppose it is given a perpendicular velocity, then it will revolve in a circle, horizontal circle like this. Suppose the r is the radius of this conical pendulum, and suppose h is the height of the conical pendulum, and L is the length of the string here. Then we can see clearly that the forces acting on this pendulum are nothing but one is mg, that is downward direction. Weight of the pendulum is going to be in the downward direction. The second is the tension in this string here, that is T, and the third is the centrifugal force, which is acting along the radius away from the center of the circle. This is the center of the circle, C here, and O is the point of suspension where this pendulum is suspended from. Okay, तो ये है अभी इस T को हम जो है दो components में resolve कर सकते हैं आराम से. Okay, we can resolve this tension in the string in the two components, one of which will be along this horizontal and other one will be along the vertical like this. And as we know that this angle is going to be theta, and this angle is same as this here theta, so we can resolve this T into two components. Vertical component will be T cos theta and the horizontal one will be T sin theta, right? And hence we can say in equilibrium that this T sin theta happens to be actually equal to Fc, and this T cos theta is actually equal to mg, correct hai? So that we can just get this ratio. If we take the ratio of these two, then we get this T cancelled and get that sin theta upon cos theta, that is tan theta, which is going to be actually equal to Fc upon mg, correct hai? And if we replace this Fc by mr omega square, अब यहाँ पे T मतलब क्या है, टेंशन इन द स्ट्रिंग है, उसको हम चाहिए तो T डैश बोलेंगे तो बेटर होगा, क्योंकि टेंशन T is reserved for period of pendulum, period of this conical pendulum, time period of revolution, ठीक है ना, which is the time required for completing one full revolution along the circle here. So this will be the ratio, and this tan theta will actually be equal to Fc के बदले अगर हमने mr omega square अगर डाल दिया तो ये देखो mr omega square upon mg, so that this m gets cancelled from both the numerator and denominator, and we are left with tan theta is equal to r omega square upon g. But actually from this triangle, if you see carefully, if this see this triangle, so in this triangle the angle above angle is theta, so we can say that the tan of this theta will actually be equal to the opposite side upon adjacent side. ये तुमको पता है tan theta का वैल्यू क्या होता है, opposite side upon adjacent side. So according to that we can get this another value of tan theta, which is nothing but r upon h, correct hai? And if we just equate both of these values of tan theta here, then we can get simply that is r omega square upon g is actually equal to r by h, and hence r gets cancelled from both sides, and hence we get this omega square to be equal to simply g by h, and hence omega actually becomes equal to root of g by h, and hence period of conical pendulum actually becomes equal to 2 pi by omega. Already हमको ये formula पता है, 2 pi by omega is the period, so we can just put it here and get this as 2 pi by root of g by h, and then just reverse this and get this expressed as 2 pi root h by g, and this h can also be expressed in terms of L and theta, because we know that if you consider this triangle once again, इसी ट्रायंगल के अंदर अगर हम देखते हैं ठीक से, ये देखो ये वाला जो ट्रायंगल है, तो इस ट्रायंगल के अंदर देख सकते हो आराम से कि cos theta will be equal to what? Cos theta will actually be equal to the adjacent side here. This is adjacent side, sorry, adjacent side upon hypotenuse, correct hai? That is the definition of cos theta. So we can say that this cos theta will actually be equal to h upon L, correct hai? So that we get this h to be equal to L into cos theta. So if you put this value of h here in this formula, then we can get this simplified as L cos theta in upon g, correct hai? So this is actually the correct formula for conical pendulum, period of conical pendulum. So period of conical pendulum is given by 2 pi root L cos theta by G. Remember this correctly, and remember learn this formula as it is. Okay, and remember that this T dash is different from T here. T dash stands for tension in the string here. ये T dash मतलब क्या है, यहाँ पे टेंशन है, जबकि यहाँ पे T माना क्या है, it is going to be the period of revolution. Okay, the period of revolution, that is the T here. This is basically the conical pendulum. Okay, one more thing is that here these three quantities H, R and L are also related among themselves by Pythagoras theorem, that is h squared plus r squared is equal to l squared. ये भी अच्छी तरह से याद रखो, क्योंकि कभी कभी क्या है ना, h और r दिया रहता है और हमको l निकालने के लिए निकालना पड़ता है, तो ऐसे केस में हम ये वाला फॉर्मूला यूज कर सकते हैं आराम से, बिल्कुल. Okay, so this is all about the conical pendulum, and these are the formulae which we have to discuss about in this circular motion. Now just let us directly start with the MCQs based on this circular motion, uniform circular motion. Yes, I have already shared this file, this PDF file with you before in last week, I think so. तो लास्ट वीक में मैंने ये फाइल आपको शेयर किया था ऑलरेडी, तो जस्ट आई होप ऑल ऑफ यू हैव गॉन थ्रू इट एंड ट्राइड सम MCQs टू सॉल्व. तो अगर उसमें से कुछ आपको नहीं आए रहेंगे तो वो मुझे बताओ, अदरवाइज जस्ट आई विल टेक सम MCQs जो मुझे लगता है कि आपको नहीं आए रहेंगे तो वो मैं कवर करता हूँ. ठीक है, तो देखो यहाँ पे से जो सबसे पहला MCQ हम देखेंगे रिक से, the body is moving with a uniform speed v in a circle of radius r. Then the angular acceleration of the body is, angular acceleration कितना होगा, यूनिफॉर्म स्पीड से अगर वो मूव कर रहा है तो एंगुलर एक्सेलरेशन तो जीरो होगा, बिल्कुल. तो एंगुलर एक्सेलरेशन इज डिफाइंड एज d omega by dt, or we can see that the rate of change of angular velocity, right? And as we have seen already that whenever the particle performs circular motion, okay, what happens is it just traces out its radius vector, traces out equal angles after equal intervals of time, correct hai? And hence we can see its omega is always remains constant, and since omega is constant, the rate of change of that omega, d omega by dt, we can say, which is called alpha, that is nothing but the angular acceleration, it will actually be equal to 0, because it is a centripetal acceleration which is going to be towards the center and along the radius and towards the center, which is of magnitude v square upon r, okay, or r omega square or v into omega. ये फॉर्मूला किसके लिए है, सेंट्रीपिटल एक्सेलरेशन के लिए है, याद रखो ठीक से. और सेंट्रीपिटल एक्सेलरेशन इज डिफरेंट फ्रॉम द एंगुलर एक्सेलरेशन. एंगुलर एक्सेलरेशन अलग होता है और सेंट्रीपिटल एक्सेलरेशन अलग होता है. तो याद रखो, एंगुलर एक्सेलरेशन इज डिफाइंड एज द rate of change of angular velocity, whereas the centripetal acceleration is defined as the rate of change of linear velocity. Okay, linear velocity का rate of change मतलब centripetal acceleration होता है, जबकि angular velocity का rate of change मतलब angular acceleration होता है. और जबकि यूनिफॉर्म सर्कुलर मोशन के अंदर angular velocity constant होता है, तो ऐसे केस में इसका जो डेरिवेटिव है या रेट ऑफ चेंज है तो वो जरूर 0 बन जाएगा. और यहाँ पे क्वेश्चन के अंदर हमको एंगुलर एक्सेलरेशन के बारे में ही पूछा है. इफ वी सी केयरफुली, देन in case of in this MCQ here, they are talking about the angular acceleration and not the centripetal acceleration. Okay, तो याद रखो ठीक से. चलो ठीक है, the second question we can talk about is the rotation of rigid body is defined by this equation, theta is equal to 2.5 sin pi t by 4. The angular velocity of the body at t equal to 2 seconds will be. तो देखो यहाँ पे थीटा कितना दिया हुआ है, just check, 2.5 sin pi t by 4, right? So देखो 2.5 sin pi upon 4, this is the value of theta, correct है? And we want to find out the angular velocity, matlab we want to find out omega at t equal to 2 seconds, right? So how can we do that? See, just differentiate this equation with respect to time, because we know that d theta by dt is nothing but omega. So if we just differentiate this equation with respect to time, then we can just be able to get that d theta by dt is equal to d by dt of this whole thing, that is 2.5 into sine pi t, sorry, sine of pi t by 4, करेक्ट है? तो इसका हमको डेरिवेटिव निकालना है, मतलब तो सिंपली डेरिवेटिव कैसे निकालना होता है वो आपको पता है ऑलरेडी. In order to find out the derivative, the whatever is the constant will be taken out. So 2.5 is going to be a constant, so it can be taken out of the derivative sign. So the next step here will be simply 2.5. Okay, d theta by dt actually will be equal to 2.5 is taken out and d by dt of, मतलब डेरिवेटिव के ब्रैकेट के अंदर कौन बच रहा है? तो साइन ऑफ दिस पाई t by 4 ये हमारा बच रहा है अंदर. ठीक है, और जैसा कि हम जानते हैं कि डेरिवेटिव ऑफ साइन एक्स इज सिंपली कॉस एक्स, करेक्ट है? ये सभी को पता है फॉर्मूला. तो ये फॉर्मूला यूज करके हमको मिलेगा डी थीटा बाई डी टी which is going to be actually equal to 2.5 kept as it is, and derivative of this sine of this chuck which is assumed as x will actually be equal to cos of the same chuck, that is pi t by 4. But we are to not to forget to multiply this whole thing by the derivative of the chuck we have assumed it as x. ये जो इसको हमने x assume किया था उसका डेरिवेटिव निकाल के हमको उससे मल्टीप्लाई करना होता है. दिस इज कॉल्ड एज चेन रूल, रिमेंबर. तो साइन ऑफ ये जो भी फंक्शन है अंदर का उसको x assume करके हमने उसका डेरिवेटिव निकाल लिया. साइन x का डेरिवेटिव जैसे होता है cos x. So our derivative of sin pi t by 4 becomes equal to cos of pi t by 4, no doubt. But the derivative of pi t by 4 is to be found out separately and is to be multiplied here so as to get the complete derivative here. So this d theta by dt is actually going to be omega, which is nothing but the angular velocity which we want to find out. And then here 2.5 into cos of pi t by 4 kept as it is and multiplied by, अब यहाँ पे pi by 4 is the constant, so it can be taken out, and the derivative of t with respect to t happens to be 1, and that's why this pi by 4 into 1 comes out to be pi by 4 only. And in the next step now we can just get this as, first of all we'll just erase okay. So see here, so omega is obtained to be actually equal to 2.5 into ये pi by 4 जो है, जो कि यहाँ पे हमको दिख रहा है, we can take it in the front here. तो यहाँ पे हम ले सकते हैं उसको 2.5 के साथ. So here it will be 2.5 into pi by 4 and that is multiplied with cos of, ब्रैकेट में आएगा यहाँ पे pi t by 4. ठीक है, बट यहाँ पे हमको क्वेश्चन में क्या दिया हुआ है देखो ठीक से फिर से. We want to find out the velocity, angular velocity at time t equal to 2 seconds here, right? That means we have to put this time t as 2 here. So 2 seconds यहाँ पे डाल दो. We have to put this t equal to 2 here in this formula so that we get this angular velocity omega to be simply equal to 2.5 by 4 pi into cos of, this is pi into 2 upon 4. ओके क्या किया हमने, इधर जिधर भी t दिख रहा है तो उसके बदले हमने 2 डाल दिया, राइट? यस. सो अभी इसमें ये 2 जो है वो कैंसिल हो जाएगा इस 4 के साथ और नीचे 2 बचेगा, जिससे हमको मिलने वाला है ओमेगा इज इक्वल टू 2.5 by 4 into pi into cos of, what is this here? It's going to be pi by 2 here, and we know already that pi by 2 cos of pi by 2 मतलब ही कितना हो गया, वो cos of 90 हो गया, क्योंकि अगर pi by 2 को अगर हमको कन्वर्ट करना है रेडियन में, सॉरी डिग्री में, तो उसके लिए उसको हमको 180 बाय पाई से मल्टीप्लाई करना पड़ता है, ये सबको पता है। तो ये पाई से अगर मल्टीप्लाई करेंगे 180 बाय पाई से, तो ये पाई पाई कैंसिल हो जाएगा, और ये 2 जो है वो 180 के साथ रिड्यूस करके 90 छोड़ देगा, जिसकी वजह से हमको ये मिलेगा 90। तो वी कैन से दैट दिस विल एक्चुअली बी इक्वल टू 2.5 into पाई by 4 into cos 90, correct है? So here it is cos 90, and as we know already that cos 90 is nothing but 0, and 0 multiplied by anything is always equal to 0. So the answer is going to be 0 once again. Okay, just check here. This D is going to be the correct option. समझा क्या ठीक से? चलो ठीक है. The scalar product of radius vector and the tangential velocity is, yes. How can we get the scalar product of the radius vector and tangential velocity? देखो, radius vector is always directed along the radius and away from the center, correct है? So if we can draw, this is a circle and this is the radius vector, and the tangential velocity is along the tangent. So obviously we know that radius and tangent is always perpendicular to each other. So there is an angle of 90 degree between these two, correct है? So if this is r bar and this is v bar, then what is the scalar product of this r bar and v bar? It is going to be 0. Very good. 0. Very good, Athar. Since they are perpendicular to each other, and we have already seen in the properties of scalar product that if a bar is perpendicular to b bar, then the product of these two vectors a bar and b bar always becomes equal to 0, and this is the property which we can use it here. And even if we don't remember the property, the definition of a bar dot b bar we already remember that a bar dot b bar equal to क्या होता है, mod of a bar into mod of b bar into cos of theta होता है, correct है? So if we use this here, then we can get this r bar dot b bar will actually be equal to mod of r bar means r into mod of b bar which is v into cos of this 90 here, and cos 90 as we know already it is 0. So this since this cos 90 is 0, this everything will become equal to 0, and that's why the product of scalar product of radius vector and the velocity vector is always going to be 0. Once again this third time. तो देखो तीनों MCQs के आंसर 0 आ रहे हैं, देखो ठीक है. चलो focus on the next MCQ here. That is the radius of Earth is 6,400 kilometer. The linear velocity of the point on the equator is nearly equal to. So see here, radius of Earth is given, and we want to find out the linear velocity of the point on the equator. So suppose that yes, suppose this is the Earth, okay, and it is rotating about its axis like this. The radius of Earth is already given, which is 6,400 kilometer, and suppose this is the object which is placed on this equator. So this object will also be revolving along with the Earth in a circular orbit of the same period as that of the period of rotation of the Earth. And we already know that the period of rotation of the Earth is nothing but 1 day. Okay, 1 day. एक दिन के अंदर Earth जो है वो पूरा घूम जाता है about its own axis, right? And that's why the period of rotation of this particle will also be equal to 1 day, which is going to be actually 24 hours, which is going to be actually 24 into 60 minutes, which is actually going to be 24 into 60 into 60 seconds, because 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. And that's why we can say that this number will be the total period of revolution of Earth, correct hai? Which happens to be actually 86400 seconds. Remember this number correctly. You will need this number many times in physics, not only in circular motion, but even in upcoming chapters also. So remember that the time period of rotation of Earth is going to be 86,400 seconds. Remember, and this number is also very interesting to see. 86400. Okay, so if we note carefully, all these are the even numbers from 0 to 10, and they are also in decreasing order. Actually, if we write all the even numbers in a decreasing order, then it will be 8, then 6, then 4, then it should be 2, and then it will be 0. 2 is missing here. Okay, just that is to be remembered. Or we can remember like this: 8, 6, 4, and then 2 zeros. Okay, 2 zeros. So we can remember. कैसे भी करके याद रखो इसको, ठीक है? So if you remember this, then we can just get the linear velocity of this particle here at the equator, because we know that v is equal to r omega. But again, omega is the problem. How will you find out omega? We know this time period t, so and we know that omega is connected directly with time period t, as the formula omega is equal to 2 pi by t, as we have just seen. So if we try to find out this omega, then we can get this omega is equal to 2 pi by t, and this value of t here can be put here in this formula so as to get this omega, no doubt. And finally we have to find out the velocity, linear velocity, which will actually be equal to r into omega, where r is nothing but the radius of circular orbit, which is nothing but the radius of Earth itself. So the final formula will be r into 2 pi by capital T. Yes, and then just we can solve this further so as to get r. R is going to be 6,400 kilometer. Just let us check the answer options. Options we see that is it in kilometer per hour, right? So that means ये जो हमको किलोमीटर में डिस्टेंस जो है वो किलोमीटर में रखना है और टाइम जो है वो आवर में रखना है. That means you don't have to convert this into seconds here. तो ये seconds में हमने जो convert किया तो वो गड़बड़ किया, वो कोई जरूरत नहीं थी एक्चुअली, क्योंकि हमको आंसर किस में चाहिए, किलोमीटर पर आवर में चाहिए. So just keep this time period in 24 hours only. आर में रखो उसको. तो यहाँ पे 6,400 किलोमीटर में आ गया into 2 pi as it is, and here t is going to be 24, so that we can just divide this 2 and 24, leaving behind 12, and also we can just reduce this. तो यहाँ पे क्या आएगा, 4 3s are and 4 16s are 00 as it is, so that we can get finally this as 1600 into pi by 3. Correct है? But don't forget that this value of pi is actually 3.14. Correct है? So we can just get this as 1600 into 3.14 divided by 3. Okay, that means it is approximately equal to 1600 only, right? So we can call it as 1600 kilometer per hour. Okay, approximately. 1600 से थोड़ा ज्यादा होगा वो तो आपको ऑप्शन में पता चल ही जाएगा. ये देखो 1675 kilometer per hour. Okay, so this is going to be the best option, which is nearest one. Yes. Let us see the next question. The particle is moving along the circle of radius 3 meter with a constant speed 9 meter per second. It covers a quarter circle in the time. Okay, क्वार्टर सर्कल कितने टाइम में वो कवर करेगा, तो वो हमको ढूंढ के निकालना है. बराबर है? यस. सो जस्ट ट्राई टू सॉल्व दिस. देखो, अगर ये दिया है कि रेडियस 3 मीटर है और स्पीड उसका 9 मीटर पर सेकेंड है, तो उससे तुम उसका पीरियड निकाल सकते हो क्या? क्योंकि क्वार्टर सर्कल के लिए उसको जो टाइम लगेगा वो पीरियड के 1/4 होगा. उतना तो समझ सकते हो आराम से. तो वही हमको पीरियड निकालना है पहले, और पीरियड का 1/4 करना है, बस खत्म. तो पीरियड निकालने के लिए हमको क्या दिया है, एक तो रेडियस दिया है और उसका स्पीड दिया है. और हमको पता है ऑलरेडी कि रेडियस एंड स्पीड आर जस्ट कनेक्टेड विथ ईच अदर बाय यूजिंग अ फॉर्मूला. See here, if suppose this is the circle and ये suppose circular motion परफॉर्म हो रहा है, तो उसका रेडियस जो है वो रेडियस दिया हुआ है 3 मीटर और स्पीड जो दिया है वो है 9 मीटर पर सेकेंड, करेक्ट है ना? देखो 9 मीटर पर सेकेंड इज द स्पीड एंड रेडियस इज 3 मीटर्स। ओके, सो इससे हम पता कर सकते हैं कि टाइम पीरियड ऑफ द पार्टिकल इज गिवन बाय द फॉर्मूला 2 पाई r अपॉन v, करेक्ट है? So time period can be found out easily, that is 2 pi into r. R means 3 and that is to be divided by v, which is 9. So that this 3 gets cancelled with 9, leaving behind 3, and we are going to get this period of revolution, that is 2 pi by 3, correct है? Yes, but if suppose we want to find out the quarter circle, तो देखो quarter circle के लिए कितना टाइम लगेगा? तो देखो ये पीरियड मतलब क्या होता है, अगर पार्टिकल यहाँ से स्टार्ट करता है तो पूरा चक्कर काटने के लिए जो उसको टाइम लग रहा है तो उसको हम बोलेंगे टी, करेक्ट है? टी इतना टाइम उसको लगता है, नो डाउट, पूरा चक्कर काटने के लिए। इफ वी डिवाइड दिस होल सर्कल इन 4 इक्वल पार्ट्स लाइक दिस, तो 4 बराबर पार्ट में टुकड़ों में अगर उसको बांट देंगे तो यहाँ से यहाँ तक उसको ले जाने के लिए कितना टाइम लगेगा? जरूर t/4 टाइम लगेगा। आगे यहाँ से यहाँ तक जाने के लिए t/4 टाइम लगेगा, और तीसरा क्वार्टर सर्कल कंप्लीट करने के लिए भी t/4 और चौथा वाले के लिए भी t/4। तो चारों क्वार्टर सर्कल्स कंप्लीट करने के लिए जरूर उसको t/4 इतना टाइम लगेगा। और वही हमको पूछा है, what is the time required to cover quarter circle? So the time required time will be actually t/4, and this t/4 will actually be equal to 1/4 of t, and t is nothing but 2 pi by 3, right? So if we just reduce this, then we get this 2 ones are and 2 twos are, so that we get this as pi by 6. But just check the options, are they in the decimals? No, they are in pi, in terms of pi only. So pi by 6 only is going to be the correct option. Okay, B is going to be actually the correct option, correct hai? Chalo, next one, just try this sixth one here. A particle of mass m is moving in the horizontal circle of radius r, okay, and with the uniform speed v. When it moves from one point to diametrically opposite point here, then its kinetic energy will change by mv square by 4, or the velocity doesn't change, or velocity changes by 2v, or kinetic energy changes by 2mv square. See here, remember one thing, that the kinetic energy is nothing but a scalar quantity. I already explained this in the first lecture of uniform circular motion itself, that kinetic energy is going to be a scalar quantity. So it doesn't change at all in a uniform circular motion, but velocity changes certainly. So because of that, ये kinetic energy changes by mv square upon r, ये 4, ये तो option wrong हो गया. Even kinetic energy change by 2mv square, ये भी option wrong हो गया. And we know already that the velocity changes certainly. ये definitely हमको पता है कि velocity change होता है, तो ये भी option इसका मतलब wrong हो गया, B option जो दिख रहा है यहाँ पे, क्योंकि वहाँ पे क्या बोला उन्होंने, velocity doesn't change बोला है, जबकि हमको पता है कि velocity changes. So बचा कौन सा ऑप्शन? फिर ये सी ऑप्शन ही बचा हुआ है जो कि राइट होना चाहिए. The velocity changes by 2v, and the reason behind it is that, see, when we consider the circle, and suppose we consider the diametrically opposite point, suppose the particle start from this point and just move to the diametrically opposite point here, suppose यहाँ पे वो जाके पहुंच जाता है, तो at this point A here, the velocity of the particle will be directed upwards, and we can call it as v1 bar, okay? And here, when the particle moves to the diametrically opposite point B here, the velocity of the particle will be directed downwards. We can call it as v2 bar, okay? And now the change in velocity here, change in velocity, okay? How will you find out the change in velocity here? v2 bar minus v1 bar. But already we know that these two are the opposite vectors, right? So since these two vectors are opposite vectors, so v2 bar is downwards and v1 bar is upwards. So can't we write that v2 bar is actually going to be minus of v1 bar, correct hai? So or v1 bar can also be written to be equal to minus of v2 bar, and hence we can just replace this one for another and get that v2 bar minus, अब यहाँ पे v1 bar के बदले क्या आएगा, minus of v2 bar आएगा, जिसके कारण यहाँ पे v2 bar minus of minus v2 bar will be 2 times of v2 bar, correct है? and that means 2 times of v. This is the magnitude of that velocity, change in velocity. So the magnitude of change in velocity is going to be 2 times of v, which is the option C here, which is correct one. And even we can solve this by another method. See, when the particle turns through, moves from one point to diametrically opposite point, so it turns through a 180-degree angle. Do you agree with this? ये 180-degree angle से वो turn होता है. और change in velocity के लिए हमने formula क्या derive किया था last time, याद है? तो delta v is actually going to be 2v sin theta by 2, correct है? And if you put this theta equal to 180 here, then we can get this 2v into sin of 180 by 2, and hence we can simply get it as 2v into sin 90, and sin 90 is nothing but 1, so that we get this 2v into 1 matlab 2v. So this is nothing but the change in magnitude of change in velocity of the particle when it turns through 180 degree. That means it moves from one point to diametrically opposite point here. Yes. Okay, what is the power needed in uniform circular motion? 0. Remember, because in uniform circular motion, no work is done. Why? Because, see here, the reason behind it is that the work done is defined as force into displacement. Actually, it should be the dot product of force and displacement, right? So whenever the particle performs a circular motion, in this case, the force is going to be the centripetal force, which is Fc here, and the displacement is going to be along the tangent, right? So centripetal force is the radial one, and the tangent displacement is along the tangent. So there is an angle of 90 degree here, and since the angle of 90 degree is there, the dot product of these two vectors will be 0, and hence you can say that the work done is also 0. And since no work is done, the power will also be 0, because power is actually defined as work upon time, correct है? तो वर्क ही 0 है, तो पावर तो 0 ही होगा ना जरूर. तो इसलिए हम कंक्लूड कर सकते हैं यहाँ पे कि पावर इज 0 इन केस ऑफ यूनिफॉर्म सर्कुलर मोशन. रिमेंबर करेक्टली. Yes, then the eighth question, the angle between radius vector and centripetal acceleration is 180 degree, matlab pi radian. See why? Because radius vector is going to be along the radius away from the center, but centripetal acceleration is directed along the radius towards the center. So both of them are just opposite to each other, and that's why the angle between them is going to be pi radian. Ninth one, to enable the particle describe a circular path, what should be the angle between its velocity and centripetal acceleration? Velocity is tangential and centripetal acceleration is along the radial. So there should be an angle of 90 degree between that. Okay. Then again, we'll see the car is traveling at 30 meter per second on a circular road of radius 300 meter. Okay. It is increasing at the speed of 4 meter per second squared. Then the acceleration of the car is. ओके तो यहाँ पे एक्चुअली ये क्वेश्चन जो है वो तुमको नेक्स्ट ईयर सॉल्व करने के लिए बेटर होगा, क्योंकि उसके अंदर एक टेंजेंशियल एक्सेलरेशन का एक कंसेप्ट आता है जो कि हमने अभी तक नहीं डिस्कस किया है. तो चलो ठीक है, अभी फिलहाल हम इसको ऐसे ही सॉल्व कर देंगे कि जो सेंटीमीटर एक्सेलरेशन पूछा है करके ऐसा सॉल्व कर देंगे. तो सेंटीमीटर एक्सेलरेशन का फॉर्मूला क्या है हमारे पास? वी नो दैट सेंटीमीटर एक्सेलरेशन इज सिंपली द v स्क्वायर अपॉन r. करेक्ट है. सो यहाँ पे हम सेंटीमीटर एक्सेलरेशन का फॉर्मूला लिख देंगे AC is equal to v square upon r, where v is going to be 30 here, okay, and r is going to be 300, right? So that we can just put it here. So 330 का square और उस divided by r, which is 300, and hence we can get this as 900 divided by 300, which happens to be actually 3 meter per second. So this 3 will be the answer if it is the centripetal acceleration to be found out. Okay. चलो ठीक है. So just try to solve all these questions at home on your own. Okay. So that we can discuss the doubts next time. ये सारे जो questions है वो थोड़ा सा try करो घर पे. Almost ज़्यादा नहीं है, कितने एक almost these questions here. Yes, it's okay. There are 40 questions. Okay, just try them out your own or on your own. Try to solve them and just discuss the doubts next time. Okay. So, let us stop here. Thank you all of you.